Hello, we are Denisa, Pricopi and Georgiana Alecu, and this video focuses on our computer graphics programming mini project. For this project, we chose to implement a shader and look at the current state of the art within the subject. In the field of computer graphics, shaders are computer programs used to do shading. They are used in cinema, post-production, computer-generated imagery, and video games with the purpose of producing a very wide range of effects. Shaders are most commonly used to produce lighting and shadow in 3D modeling. However, these are not limited effects. Among the different types of shaders, there is toon shading, which is basically a type of non-photorealistic rendering. It is designed to make 3D computer graphics look flat, and it is often used to reproduce the style of cartoons. As you can see in this picture, there is a visible difference between a plastic shader and a toon shader, especially in terms of materials. Research shows that in recent years, toon shading has proven to be quite popular in 3D renderers, animation, and video games. The image that is presented here shows three spheres generated in the 3D program Blender. From left to right, the light source does not change. However, the difference in display is quite significant, and that happens only by manipulating the rules for shadow and light reception of these materials. And this is what is understood by the power of shading. The furthermost right sphere is shaded with what is generally accepted as cell or toon shading. If we look at it closely, you can notice that both shadow and light drawn onto the material have hard edges and do not feature a soft gradient like in the other two examples. This technique is often used in traditional animation because flat and crisp shadows are faster to draw by hand than color gradient shading. When we look at traditional animation, we can see that many of them involve elaborately painted and static backgrounds, but use quite simple shading techniques and flat colors for their animated characters. As we can see in this example from Gravity Rush the game, where the shading on the character is quite flat, involving the lighted area and the shadow quite simply and in only two colors, whereas the background is a little bit more complex. This is basically the main reason we chose to focus on a toon shader. Further on, we would like to look into various toon shaders in order to investigate what are the differences among them. Then we will present the current state of the art of a few different toon shaders and compare 4 implemented ones in terms of properties. In the end, we will talk about the code of our implemented shader. Although many different techniques have developed in past recent years in non-photorealistic rendering, there has always been one common goal for it, namely that of taking images or models and being able to produce something that looks as if it has been done by the artist, just as we've seen in the previous example. The idea behind toon shaders is quite basic, as much research puts it. The 1D texture coordinate is determined by the dot product between a light vector, which in this case would be the L, and a surface normal, which is the N. And then shading is employed through the coordinates to present light and dark transitions on the surface, as we've seen in previous examples. However, others work to expand upon the basic toon shader. For example, Barla and the collaborators have expanded upon the classic 1D toon texture mapping by adding a vertical detail axis meant to build a 2D toon texture, and this basically means that besides the horizontal axis, which corresponds to the dot product between N and L, they added a secondary vertical axis which corresponds to the toon detail, where each value along the axis corresponds to its own 1D toon texture. Their purpose was to be able to highlight the near silhouette region and stimulate limited materials. In this figure, they illustrate how they use a plastic and metal highlight. In the B figure that we see, they use a highlight texture that decreases in width, which gives the model a plastic toon highlight. In C, they use a texture that creates a glowing highlight, thus resembling a metallic material, whereas in D, they modify the color of the highlight, making it rather near its boundaries when it reaches a given scale. How, When, and others have been investigating the Toon Shader by Barla further on, their main contribution being the extension to more materials such as gouache, metal, and wax, but also the ability of depicting more details of the models, since their main purpose was to obtain more stylized silhouettes. As you can see in this picture, this is what they focused on, and when applying a mesh sharpening, they were able to obtain a much more precise and detailed silhouette of the same model. When it comes to state of the art, for our project, we have been inspired by David Vargenhill's research from 2011. Their purpose was to provide a single approach to create various dynamic stylized shading effects, and the key to their approach is to seamlessly vary appearances by using a combination of shading primitives by taking into account lighting direction, material characteristics, and surface features. The most important part from their work, however, is the shading parametrization, which is also the most important part for our work. They illustrate how by varying the alpha value, different shading behaviors are continuously produced, from diffuse when alpha is equal to 0 to specular when alpha is equal to 1, and to a more controlled one when alpha is equal to 0.5. Hi, I'm Denisa, and I'm going to talk about the more technical part of this mini project. First of all, as Georgiana already mentioned, Toon Shader or a cell shader is a rendering technique that is mostly used for simulating the hand-drawn cartoons. Usually, light creates a gradient on an object's surface using its normals. Cell shading polarizes the gradient, making a pixel be lit or not by the light. The dot product between the light direction and the surface normal, which you can see in this line of code, defines the amount of light a pixel receives. Rounding this value to 0 or 1 or defining different grades or cuts will result in a different cell shading style, as you can see with these three different objects in the scene. Usually a shader has three main components, namely diffuse shading, one for the lighter area and another one for the darker area. It also has specular highlight, which represents where the light hits the object, and of course it has an outline. So this is our scene with 4 different shaders. We have our implemented shader. We also have another one, a diffuse shader that comes as a standard shader from the Unity. We have a Toon Shader that is also from the standard one from the Unity, and we have another Toon Shader that has applied a certain texture to it, and it also has a bit of transparency. A particularity of our shader is that, as you can see, the shininess, it changes its dimension and its position depending on how the light hits the object. The Unity Toon Shader uses its own texture, so basically what you can see on this object is a texture and not necessarily a light effect. When it comes to our material and actually to our shader properties, we have a diffuse material color, which basically represents the lighter color of the object. We also have the unlit color, which is the darker shade of our object. We also have a lightning threshold, which gives how the amount of shadows the object will have. We also have a specular material color, which is always white and represents the white spot on the object. We have the shininess, which changes the dimension and the form of the white spot on the object. And of course we have the outline thickness, which allows us to change the outline. In terms of code, this is how it looks like. We have on the top part of the page the properties of our shader. You can see there that there is a color, unlit color, diffuse thresholds, spec color, shininess, outline thickness, and main text, which is the texture. Those are all the things that we talked about before, that you can basically change on Unity. Then we have the subshader, which contains the CG program, a Pragma vertex vert, which tells the CG to use a vertex shader called vert, and a Pragma fragment frag, which tells the CG to use a fragment shader called frag. Then we have the Toon shading uniforms, which basically declares all the variables that we are going to use. Then we have the struct vertex input, which tells Unity what is going on and how to use the variables. Also we have a struct vertex output, which basically returns the variables that we need. Then we have the most important part of our shader, which is vertex output, and that gives us information about how the light is behaving. We are calculating the normal direction by multiplying the input normal with the inverse model matrix, transforming the normals from objects to the world space. We get a normal direction unit vector. We also calculate the world position by multiplying the object world with the input vertex, transforming the local space position to the world space. About the view direction, we subtract the position of the world from the position of the camera, which is the normalized for obtaining the unit vector. For the light direction, we calculate the light direction depending on if it's directional light or point light. We are using the lerp operator, which interpolates the world space position and the fragment light source and the world space light source. Then we have the fragment shader, which contains the dot product between the normal direction and the light direction, and that is already normalized. In this part of the code, we also calculate the diffuse threshold, the specular threshold, and calculate all the outlines. And this is it in terms of coding. We are also going to present you some of the sources we used in order to implement the shader. We used Wikipedia. We found about some stuff about processes and cell shading in video games. We also found some other interesting websites that we used as an inspiration for our code: Next Generation, Cell, Unity.
We found a bunch of different ways of doing shaders. We are going to leave some hyperlinks to all the sources that we found. Based on the research we've made, we can conclude that there are many different types of toon shaders which can be used based on the game developer's needs. This is kind of it with our project, and thank you for watching.